Good afternoon. Welcome to What's New for Developers in Yukon. My name's James Hamilton. I've been with the SQL Server development team since the 7.0 timeframe. Prior to that, I worked for about 13 years. Last job was lead architect on DB2. In the 15 years or so that I've spent working in the database community, I've seen three broad classes or phases of development that the relational community has gone through. The first phase, looking back in time, was one of proving that it actually worked. Believe it or not, for a long time there was really serious doubt with whether a relational database management system would ever scale and perform sufficiently well. I joined the community around the time frame that was becoming established. I helped get some major benchmarks finished. I remember a major breakthrough for us was getting TPC-A down below 100,000 transactions. If you think about that, it's pretty impressive. That's 6 database interactions, and of those 6 interactions, getting it below 100,000 instructions. At that time, we were running around 2.4, 2.5 cycles per instruction. So pretty impressive throughput rate to be able to get that done in that kind of speed. We've improved by a factor of 10 or more in the subsequent years. Believe it or not, it's still the case that products, non-relational products, still are somewhat faster. What happened, the best I've seen is around 35,000 instructions for that same benchmark. What happened is they're close enough that the ease of use of a relational system, the ease of management, the ease of maintenance won out. It's pretty much an established story. Structured data is stored in a relational database. That's just the way it is. The second major phase, and this is the phase that attracted me to Microsoft SQL Server team. Picture this. I've been working for a number of years in the database community. It's an opportunity to start from scratch, to build a new code base over 2 releases. And here's the game plan. The game plan with SQL Server is build an enterprise-class data management system with enterprise-class scaling and enterprise-class performance, but don't build in enterprise-class administration costs. Do the same thing that we already know how to do, but now do it so that it's cheaper to administer. We've pursued that mantra at SQL Server for 2 releases now. We are the leader in the community in that space. We've made relational database systems available to small and medium-sized business at a cost-effective manner. It's been fantastic. I've really enjoyed the last couple of releases. The third phase is what I'm going to talk to you about today. The next big change in the database community is in server-side programmability. That's phase 3. If you look at systems today, IBM uses persistent stored modules. Oracle uses PL SQL. We use T-SQL. The common theme across all these languages, they're not wonderful tools. They don't have great tool support. They don't have a lot of the concepts that we expect to find in a modern language. They're just not there. So phase 3 is, keep going, stay focused on performance, stay focused on cost of administration, but phase 3 is reducing the cost to develop code for database engines. I'm going to start off by looking first at a little bit of evolution and programmability and predicting where we're going for the next few years, and then I'll show you what we've done in Yukon to fill out that vision. Where we see databases going, Yukon is a substantial step along that path. It's taken quite a few years to get where we are. Believe it or not, some of the things that I'm going to talk to you about, one of the projects, the first one in fact, the .NET integration, that didn't start at the end of the last release. That started just after the end of 7.0. This investments have been going on for years. It's a real honor to be able to come here today and talk to you about it in more detail. This is the first public discussion of this code. I think it's a big step forward, and I'm very proud to be here, representing hundreds of people back in Redmond that have been contributing to this effort. Second thing I'm going to talk about is huge steps forward we've taken in the data access area and programmability in general. On XML, this is an important topic. XML is an opportunity for us to expand the classes of data that can be stored in a relational database. I told you earlier that the game was more or less played. If it's structured, it's going to be stored in a relational store. If it has schema that's rigorously enforced, it's stored in a relational store. But there's a huge amount of data, in fact, an embarrassingly large amount of data, that never finds its way into a relational database management system. And the reason for it is it's just too hard. A lot of the data doesn't have rigorous schema. It's not sufficiently well specified. There's a large number of reasons why it'll just never be stored in a full schema. If we support XML storage, we can expand the classes of data that can be efficiently stored into the product itself, and that, of course, brings more value to customers. Web services support. You've seen all of the talk about Indigo, and you've seen something spreading out through the entire company. What we're focused on is we believe the future of applications is no longer large monolithic knots. It's cooperating groups, cooperating federations of web services. That's the most efficient way to write applications, and more than that, it's the most efficient way to evolve applications going forward. They're easier to evolve, they're easier to change, they're easier to adapt, they're easier to debug. We've got great tools in this space. SQL Server is one of the products that we're investing in heavily to play into web services. And I'll show you, in fact, we'll give you a demo of exactly how this looks. Let's look back in time a little bit. When databases were first released, relational systems, fixed set of data types, fixed set of built-in functions. If you wanted to have, for example, a geographic information system point, you had no way of storing that in the database. It wasn't possible. If the database team didn't release a specific function that you needed, say GMT time, then there's no way to implement it in the store. It wasn't possible. Now, the problems you run into with this are store teams, like the one I work on, are of bounded size, and our skills are really focused on high-scale enterprise database management systems. We're not specialists in every field. So tax functions, that's a very useful thing. Wonderful to have that support natively in the database. We're never going to build it in. I gave you the example earlier of the geographic information system. Again, super important. We don't have the skills. It's not our area of expertise. What I'm going to show you today is opening up the database, allowing those functions to be added by independent software vendors. It has wonderful impact. It helps them. They have a new opportunity to make money. It helps us, our products made richer, and it helps our customers, more value to them. So the first form of extensibility that was added to database products were stored procedures. Mid-'80s, this became a huge thing, especially in New York and the financial community. The two drivers of stored procedures are, one, an abstraction layer, a higher level of abstraction. The reason why that's of value is, say you're inserting a customer record. If every application program in the business has to remember when you insert a customer record, make sure you insert both phone number records and make sure you insert the address record, and don't forget to assign a unique customer ID. The chances of that being done properly, there's risk. There's real risk. So raise the abstraction level. Create a stored procedure called create customer. Lock down the base tables so nobody can change them directly. And the only way to change it is called the create customer stored procedure. Suddenly, business logic is enforced properly. There's no chance of forgetting data because it can be checked by that stored procedure. So, higher level of abstraction. Also important for security. The reason why it's important from a security perspective is higher level abstractions have less surface area. Rather than opening up all those tables I described, lock them down, show a few views, show some stored procedures. Secure those. Simpler to secure, easy to understand the security, and as a consequence, more secure. Second big reason stored procedures are used are to cut down the sort of a part A and part B. There's a response time advantage and there's a scalability advantage. The response time advantage is, remember we talked about TPC A and B earlier? TPC A is 6 interactions. If you had to go in and out of the store 6 times, you could never make that 100,000 instruction budget. So the way it's implemented is a stored procedure. Single interaction with the database, single returned result. More efficient. It improves response time, but that's not the important thing. It's important. What's really important is reducing the load on the server. Every time you go in and out of the store, it's about 50,000 instructions. Networking is not free. As a consequence of that, reducing the number of network interactions is a big win. Second big win is there are times when moving the function to the data is much more efficient than moving the data to the function. So you can always select out all of the data, operate on it, and store it back. But when there's large amounts of data and the computation is relatively cheap, it's much cheaper to do it in the store. It's kind of counterintuitive when you think about it. If you say, hey, I want the store to scale better, so I'm going to take some code and I'm going to run it in the store. But in fact, that is more efficient sometimes. If the cost of getting it out was more than the cost of the operation, leave it in. So these are the drivers behind stored procedures. They've been really important, but what's wrong with them is the programming languages that are supported, PSM, PL-SQL, T-SQL, they're weak. So where we're going as an industry, stepping forward, is we're going to real server-side programming languages. The data-intensive code is still going to run on the server for the reasons I told you. We're not going to increase that. We're not going to decrease it. It just means that every application of substantial size is going to have some portion that's written in the server. That's going to continue to be true. We're going to have symmetric programming language support. So the same support you would have gotten in the client tier and the mid-tier, the same tools support, the same programming languages, the same debuggers, the same education, the same training, you name it. All that will be available in the server as well. We're going to leverage advances in modern programming languages. I don't know how many times I've had requests in T-SQL for better encapsulation for very large development teams. You need some way to control namespaces. Exception handling, something we did add to T-SQL, but it's been a request for a long time. Abstract data types. All of these facilities need to be made available on the server side. Even more important than that, I mean, I love the tools. I think JITted languages are super efficient. Garbage collection is a wonderful thing from a robustness perspective and a programmer productivity perspective. The frameworks might even be more important. Think of the power available in the frameworks that you've seen in WinFX over the course of this week. There's a lot. You see 50,000 line programs being rewritten this morning in 3 lines. Not all of those frameworks make sense in the store. Clearly, you don't want UI in the store, no question of that. But a lot of those frameworks really increase programmer productivity. So pulling those into the store is another thing that we will be doing. So you see our vision. Our vision going forward is we believe that the next big frontier is high productivity on the server side. It shouldn't have to be so difficult to write server-side code. .NET, WinFX, that is the future. That is where we're going. That is how we're going to achieve this vision. I want to show you more details on what we're doing. In the previous release, we had 3 extensibility points in SQL Server. The first was user-defined functions, the second was stored procedures, and the third were triggers. All of those extensibility points, those are points where you can add code to the store, all of those points are implemented in T-SQL. In Yukon, stays true, but in addition, you can write C#, VB, manage C++ for any of those 3 extensibility points. In addition to that, you now can write user-defined types and user-defined aggregates, also VB, C#, manage C++. Now for data access, when you're running in the store, clearly data access is very important. ADO.NET is supported. It's a special version of ADO.NET because instead of what you don't want to do when you're in the store is go out to the network, come back in. So it directly accesses the engine data structures from ADO.NET. But the beauty of it is it's the same programming model. It's the same set of APIs supported in the server as we have outside the server. Security. Anytime you're running real programming languages in the server, the impact of that is, wow, real languages have real capabilities. How do you control that? How do you avoid that being a risk? We have 3 classes of security we've introduced. The first class, and this is the one that most programmers should be using, is called Safe SQL. Safe SQL is exactly the same capability and power that you'd have with T-SQL. What can you do? You can compute, you can access data, you can't go to the network, you can't go to the disk, you can't go to the registry, you can't cause trouble. It's just computation and accessing data. It's what you want. However, there are some programs you can't write with those facilities, so we need to allow a little bit more. Here's an example. Yesterday I was talking to a leader from Quest Communications, and what he was saying to me is they have a real problem with address normalization. He's bought this program that normalizes customer addresses, and the reason for it is you want to be able to figure out James Hamilton of this address and James Hamilton of this address is in fact the same person. So they bought a program that does address normalization. The unfortunate thing is it's not in the database. So you have to take data out, normalize it, put it back in. It's not a disaster. It's just not as smooth as you'd like. So he and I were talking, and I said, it's amazing. If you were using an external access stored procedure, that's the next level of security. What's available in external access is the code's still verifiable, it's still safe, but now we allow it to go to disk or to go to the network. So what you can do with that is we can write a function called address normalize, register with the database, and now it calls that address normalization package that he bought, pulls the result back, and that function is available in the database. You can't tell we didn't write it ourselves. You can select address normalize of customer address. You can compare address normalize of a customer address to a literal. It's just like any other built-in in the system. So this is giving you an idea of the kind of power we're after here. And think what it allows you to do. Every time you've got an interesting facility available, heck, a math library, if it's useful, if it helps in the store, you can make it available in the store. The final form of security is wide open. And the reason why we provide the capability of wide open, this is only available to system administrators, so it's controlled. The reason why we provide this capability is we don't want people writing extended stored procedures. I've helped so many customers over the years that have just had so much trouble with extended stored procedures from a stability perspective. It's native code running in our address space. The database programming environment is terrible. It's non-productive, it's not robust, it's just not a great way to write code. The only reason people do it is there's some things you can't do without it. Now you can. You can write CLR code. So here's an example of a customer that uses extended stored procedures for a very productive thing. In fact, there's 3 of them. Protegrity, Network Security, Incorporated, and netlib.com. All 3 of these companies provide column level encryption in SQL Server. And the way they do that is they call out to an external process that's doing secret storage and key management, and they're calling native code in the store to do cryptographic functions. As a consequence of this support, they're able to write that now in managed code, much safer, much more productive, and what's that mean? It means 3 companies now can make money as independent software vendors helping SQL Server customers. That's great for SQL Server, it's great for them, they've got a good business, and it's really good for our customers. Okay, tight integration with Visual Studio is the last one. We're lucky. Microsoft has invested heavily in the developer community. You folks are what makes our products strong. We never are able to do enough with them. And so the development tools are the most important part of how Microsoft makes our customers successful. It's very seldom that someone buys only a Microsoft solution. So the tight integration with Visual Studio is a key part of the story I'm telling you today. How's it work? Well, we'll have a new project type in Yukon. The new project type is for server-side developments, for Yukon development in VS. Code's entered into it, F5 deployment into the server. Once an assembly is built, what you can do with an assembly is, well, the first thing I wanted to tell you is not all assemblies on a server are available in the database. And why is that? There's some assemblies that just aren't appropriate to run inside a database. You need to have control. So the fact an assembly is on the server the database is running on doesn't mean it's available. It's not available until it's registered with the server through create assembly. In the example I'm showing you here, it's a taxation function that we're adding. So what the taxation function does is it takes as an argument a salary and a state and computes the income tax on that. So in this example, I've got an assembly that I want to register with the server, create assembly, done. The second thing is I want to register one external method, the tax function, as a user-defined function. I don't want everything else available, so I just register the user-defined function, create function, done. At that point, the code you see in the bottom left-hand corner of the screen can now run. You see what we're doing there? We've got select the sum, that's a standard SQL Server aggregate, sum of the tax of all employees where the county is equal to King County. You can't tell that we didn't add taxation support to SQL Server. It's just a standard part of the system now. And for every interesting package out there, for every interesting extension, this same capability is available. SQL is now infinitely extensible. You can add any kinds of facility. If someone comes up with a great idea to support query by image content, an ability to search for pictures directly, we don't have domain expertise in that area, add it. You're going to make a lot of money. Customers are going to love it. It's good for everyone. Authoring, debugging, and deploying. Well, I talked about the VS integration. One of the things that I wanted to emphasize, it's a demo I saw 2 years ago, and I wanted you to see it as well. I loved it. What it was is a call from, it's a 3-tier application. They're developing mid-tier and server-side code. So ASP code's running. It's making a call into a stored procedure. The stored procedure is written in a different language. It could possibly call other stored procedures. And we debug all the way through, single-stepping all the way from the mid-tier all the way to the server tier. I was almost in heaven. I thought it was fantastic. So, Tom, show us a little bit of a VS and how we can debug and how we can develop and.
Sure.
This is a great story.
All right, let's get started. So I'm Tom Rizzo, and I showed you a little bit this morning in Gord's keynote, but we're going to drill in more detail on some of the integration between SQL Server Yukon, WIDB, how you can create user-defined functions, types, aggregates inside of the CLR. The first thing I wanted to show you here, and hopefully you can all see that computer screen, is as James mentioned, we have integrated directly into the project system inside of Visual Studio the ability to create these user-defined types, stored procedures, and functions inside of Yukon right in Visual Studio. So we can come File, New, and if I go under my language of choice, whether it's VB, VC, VC Sharp, you'll see that in your builds that you have today, this is all running the PDC build here, is if you scroll down to the bottom, you'll see this new SQL Server project. So this will create and set up a bunch of the metadata for you, and you can start writing your user-defined functions and types. But instead of doing this, I've already got one kind of pre-canned in the oven like Martha Stewart usually does. It's already going, and hopefully this screen is up there for you now. We have, at Microsoft, we're not bicycle experts, and so we decided we'd build an application for the athletic enthusiasts at Microsoft, which there aren't that many. We're actually quite usually pale white. We don't get out very often, but
I'm the prototypical one.
Exactly. I'm standing next to one of them. And so we created a very complex sort of application that someone who's in training, athletic training, would actually use. And a lot of times in athletic training, you want to use mathematical functions like MAP4, which is maximum average performance for any sort of interval. And so we're not experts in SQL Server in building those types of athletic functions. So what we're going to leverage is some of the new CLR capabilities inside of Yukon. So the first thing we'll take a look at is a little bit of our implementation. What we did was we created a user-defined type. It's going to allow us to define our type in the system for our training type of information. We didn't want to store it in all different things. We wanted one integrated object that we could use in the system. And then we have a couple of user-defined functions and stored procedures that we've written in C#. So if you look at the user-defined type here, the first thing you'll notice up here is obviously the in-proc provider of SQL Server. We've defined it up there from the CLR. And then you'll see some interesting metadata here. So user-defined types, you want to make them serializable. You want to be able to write them out into some store. In this case, we write them out, obviously, to SQL Server. Then we say, hey, this is a SQL UDT. Or we put in what our format is, and we put in that we are byte ordered, that are actually going to write out our information in a byte ordered way. And then finally, you'll see that we have to add in nullability support, because obviously columns inside of SQL Server, which can be defined as user-defined types, the properties on those, you can have null values. So you have to add a little bit of nullability support into your user-defined type. And then if we scroll through, you'll just see a whole bunch of our implementation in here. We define things like ticks, which is the tick of the computer, the byte computer as someone cycles with a heart monitor on it. You'll see that charted out in a second using this user-defined type. Time elapsed, cadence, all sort of biking things that are in that domain. So the next thing that we said we'd do is, okay, we've got our user-defined type. Now we need to create our user-defined function. And we've done this again in C# here. And we're going to use some things in the framework that T-SQL just can't do, right? I mean, there's some limitations inside of T-SQL in the core mathematical functions that it can do, the regular expressions that it can do. It's a great data access programming language, but it's not just a general programming language. So we put in some private methods in here, like interpolate between points. We use some system.math.floor. We've done some double epsilon work, all this strange mathematical things that I probably know you probably know a lot more about it than I do, but that's okay. And so you can see this is something that would probably you would take a long time to do in T-SQL. We've done it really quickly in a short amount of code inside of the .NET framework. And the final point that I'll point out here in the code is here's where we create our user-defined function, was that compute map4 function. And now before we run the application, which you'll see here, we have a nice UI that will run. We have a picture of Peter Spiro, who's one of the other James's peers in the SQL Server group. We put him on a bike. We made him bike around, and we got some readings off of him. We'll take a look at that in a second. But I want to show you the stuff that James was talking about, which is now that you've created these objects, these user-defined types, these user-defined functions, how do you actually get them into the server, register them with SQL Server? So here's our application. This is the new workbench that we showed earlier today, and you have a copy of this as well. And you see right here, here's that create assembly. So we say, create this assembly inside of SQL Server, cycle training from our DLL with that permission set that you spoke about. And we're saying use safe permissions here. And then finally, we create our type. And this uses our user-defined type. So now we can go into our T-SQL and define a column of our type, which is what we do in some other code that I won't show you here. And then finally, we can come through, and once we get in our user-defined type, we can come back and select and see what's in the server. And if we do that, we see, hey, there's this thing called training data. It has a max length. It is nullable. It is byte ordered. And here's the assembly class that we created that it maps to. And then the next step is we say, hey, SQL, we have a function. It's our user-defined function. And that actually maps to this other, in our assembly, this actual function inside of our assembly. So it's not very complex code. It's not all that hard. And you can pass in SQL data into your user-defined function and operate on that, even though it's written in C#. And then the final thing is we could come and enumerate all of the stored procedures, the managed stored procedures and functions inside of our system. We see we've got a bunch of these inside of here, the assembly methods, the assembly classes, all this good stuff. Now, we do have a bunch of test data contained in the system, and as a DBA or developer, you can come through and look at the raw information contained in the UDT. Not very exciting, right? It's binary, right? So yeah, and it's actually quite exciting. It's actually hexadecimal, I believe. But anyway, I digress. And then we can test this. So we can come through and write a little bit of T-SQL that does our map4 function with a time series that we've just placed inside of our code. And there we go. Our function worked. Not very exciting, not very interesting, but when you take the power of user-defined types, user-defined functions, and the stored procedure and put it into an application, you can actually do some exciting things. So let's go and actually run now the WinForms app that we built that will show using all these new capabilities inside of Yukon. Let's give it a couple seconds. Up pops the lovely face of Peter Spiro. And we see we're querying other information, just relational information stored in SQL. If we come to our charts, this is going to use the UDT and also the map4 function to figure out the information. So you'll see the map4 pop here. We're doing a minute of information, so we'll find it in the interval, the map4 there. We'll select all the different training zones and all this good stuff. So I'll cross our fingers. I may have to restart SQL Server if this doesn't work. Ah, there we go. So now we've charted out, and we've used our UDT. We've used all of our functionality. We can even come through and build more interesting applications where we compare all different things. So we showed you how you can write that code. The next step you may say is, okay, I've written that code. We showed you this morning. I'll show it to you again just really quickly, is the integrated debugging experience that you have between all the different languages inside of the .NET framework, including also T-SQL, which is not in the .NET framework. So this morning we showed integrated debugging. What we actually are calling is a user-defined function written in C# that calls a T-SQL store procedure that we wrote earlier. And again, you see the improc provider right here. And this is running the WIBB release that's in your kits. And then we go through and you just use ADO.NET to execute a T-SQL query, and then we call some web services below to actually use the information from a web service running on our local machine. The other thing you'll notice that I didn't point out this morning is that we have this debug SQL. In your current builds, I'm going to point out something that's in your current builds. You cannot trigger the breakpoints from client code. So for example, the scenario that James gave you, we have working back in the labs at Microsoft, but you can write ASP.NET code and call a C# procedure and then try and debug into that. That won't work in your builds today. We are going to make that work in future builds. Today you'll have to launch your debugger from directly inside of Whidbey, but we are working hard to make sure you get a build over the next couple months that will have all this great integration. So instead of talking, let's run our code. So it's compiling it, it's deploying it to the server. I already have my definitions for my assemblies. I have an object watcher down here, which will disappear in a second once it gets in. These are the parameters I'm going to pass to that T-SQL stored procedure, and then if all works well, I should get back these actual values into my object watchers. So if I step into the code, you're going to see just another bug we have here is it should, when we release, automatically pop up the T-SQL so you can step right into it. You see we have C# and T-SQL down here. Right today, I have to double click. There's my T-SQL code. I can step into that, and then if I pop back, I'm right back into C#. My objects are filled in, and I can just keep debugging as I do normally inside of any sort of .NET framework application that I create. So there you go. Quick demo of integration between Yukon and the CLR.
Fantastic. Now, obviously, we're not done yet, but you can see why I'm kind of excited about that. The capability to have proper debug support inside the store itself, from a programmer productivity perspective, substantial step forward. I mean, this is the way that we should have been doing it for years. The fact that for most of my database development years, VI was the only editor we had, and the most you could do is just print off. That's all you've got. Better world. Let's look a little bit more about, we've talked about you can run code in the store, and we talked about when you should run code in the store, but what you shouldn't hear is that you have to run code in the store. This is about choice, and this is about, I gave some rules of thumb about when you should run code in the store and when you shouldn't. It's a judgment call. The things that are important here is to have the choice and to have the flexibility to move back and forth between it. Because you're using the same tools, if code is deployed in the store and it really isn't appropriate for the store, moving it's not that hard. I was talking to a customer recently. Their application has 10,000 stored procedures. They have a very large component of their system written as server-side code. The problem they run into is if one part of their system falls behind, the engineers that are working in the mid-tier have a very hard time helping out the server-side developers. The server-side developers have a hard time helping out the mid-tier developers. You really have a partitioned dev shop, and that's a bad thing. You want to be able to have more flexibility, more choice. So that's a theme you'll hear constantly throughout this. Second thing is choice of programming languages. There is not one programming language that's the right answer for all development shops. Depending upon the skills that are prevalent in the shop and the kind of application that's being written, different languages make sense. That's what we've got to offer. So VB, C#, Managed C++ are all available. T-SQL continues to be supported and the right answer for certain classes of applications. So let me give you another rule of thumb. Anytime you have choice, you have to have rules of thumb to decide between them. So on the T-SQL side, anytime you see a extensible code that is very data intensive, lots of database access, T-SQL does a wonderful job of that, and it's really the right choice for that kind of code. It's a great choice. Code that's computationally intensive or quite large, C#, VB really tend to be better choices for that. But as a consequence of T-SQL still being the right answer for a large class of applications, we're going to keep enhancing it, and you'll see lots of changes coming up. So let's jump in and have a look at what we're actually doing on the T-SQL side. The first one is varchar max. This is a fundamental step forward. For a long time, databases have been able to store large objects. So if you have a couple gig to add to a row, we can store it. But there's a cost associated with that. The programming model for binary large objects is unpleasant. It's non-orthogonal. Most built-in functions don't operate against it. It's very much a different sort of data type. It's a weaker form of data type. So the good news is you can store it in a database. The bad news is you really can't use it for much. I hate, as a designer, anytime we come up with something that works for some types, doesn't work for others. It's a bad design. Finally, we're taking the right step on this. Varchar max. This is beautiful. Varchar max, at very small sizes, it does what you want it to do, which is store the data inline. On very large size data, like say you've got half gig of data, it stores out of line. The reason why you want it inline when it's small is you want to be able to get the row in a single I/O. It's not worth paying two I/Os for it. General rule of thumb is that all the indexing structure except the leaves are probably in memory. The leaves almost certainly aren't in memory. As a consequence, you're driving 2 IOs if you have it stored as a blob. You want 1. On the other hand, if it's very large, you really don't want to get it unless you need it, because the cost of moving a couple gig of data is pretty substantial. The best example of why this data type looks really useful from my perspective, years ago I was working on SAP and implementing SAP efficiently inside the database system. And it turns out a lot of SAP data averages 6 or 8 characters in a column. The most common case is 6 or 8 characters, but 10K is possible. So what does that mean? It means we're stuck. All the column, pardon me, has to all be the same type. Because it can be 10K, it has to be a blob. But because it's usually 6 or 8 bytes, I have all the cost of the second I/O and the inefficiencies that come with storing as a blob when it really belonged as a varchar. Now it's a varchar. It's a step forward. Another one is XML data type. I'm going to present in more detail what we've done with XML. Recursive queries. Here's a beautiful example of something that comes up constantly in day-to-day life. The way we as human beings think about things is hierarchical. If you look at part structures, they tend to be hierarchical. Parts are made up with other parts. If you look at organizational structures, they tend to be hierarchical. It's a useful way of looking at things. If you wanted to answer the question of, show me all the employees that report to Jim Alchin, it's actually kind of a painful statement to write in T-SQL today. And the reason for that is you've got 2 choices. You can write it such that it's not stable. And by that I mean it can only handle a fixed number of levels, in which case if Jim Alchin gets promoted, your code's broken. Probably a bad choice. Second way you can write it is creating a temp table and iterating level by level, filling a temp table and pulling it back out. Turns out that's very difficult code to write. It's not very difficult, but a lot of people have trouble with the code, and it's not very fast because you're iterating through it level at a time. So now it can be written as a single ANSI standard SQL statement that traverses all the way down through the hierarchy. The beauty of this is if we get a single statement to the optimizer, we do a much better job. The more information we have about what you're trying to accomplish, the better job we do of computing an access plan. So that's the advantage. And the other reason is because it's a single plan, it executes much faster. Step forward. Exception handling. Probably second biggest request that I get over the course of the last 5 or 10 years has been for exception handling in T-SQL. And the reason for it is it's mundane to keep checking after every statement the error state to see if it's gone well or not. A programming paradigm that's long been around, it's a good paradigm, is one where we can set the system up such that as long as everything goes well, it just executes through to the end. If a statement fails, we fail the transaction and run the exception handler to clean up. Nice paradigm, easy to write, easy to get right, more robust code, more stable. So that supports there in Yukon as well. Statement level recompilation. This is an interesting feature. It doesn't sound like much, but let me give you a little background. The way SQL Server works is we take batches in, either entire stored procedures or batches sent over from the client side. Multiple SQL statements. The unit of compilation is the batch. The unit of execution is the statement. The unit of optimization is the statement. So here's the problem. Say you're executing a stored procedure and you get to the 15th statement and the plan that was computed for that statement depends upon an index that's been dropped. It's okay. We can still run that statement. That's not a problem. We don't have to fail, but we do have to re-optimize. Well, what happens is you have to compile the entire stored procedure again because the procedure is the unit of compilation in order to just get that statement recompiled. As a consequence of that, it's conceivable, and in fact it does happen, where you might get multiple compilations during a single procedure execution. So now we're supplying statement level recompilation. You don't have to recompile the whole thing. So it's a great deal more efficient. And this helps in 2 different ways. One is there's less access to the metadata. It cuts down some contention, but mostly it's a better performance story. DDL triggers. We've long had triggers on insert, update, delete. We now have the capability of having triggers on statements like create table. It's really useful for our replication team. It allows them to do a much better job of replication. They can actually replicate, create tables, and add columns and interesting things like that. It also gives a lot more capability to you as well. So it's a facility that's useful both inside the system and outside the system. What's happened in data access? We've been busy. This is another one where I love talking about features that have been a big problem for a long time, or when I've heard about a lot of customers say, this causes me trouble. Multiple active result sets. The default way, or the most efficient way to return data from SQL Server is to return it as a default result set. That's the fastest way. It's the recommended way of returning data. The problem is, once the default result set begins execution, you can't execute any other statement at the same time. You'll get a server busy error. And so if you think about a common development model is select all the employees that meet some attribute, and then do some form of update on the basis of each one of those. Well, you can't do that, because once you start selecting once the default result set's coming back, you can't run other operations. Now you can. Big step forward. This makes it much easier to write code. A lot less state has to be stored in the client. You can operate in real time. You don't have to wait until the whole result set's back. You won't get surprising server busy statements. Object persistence. This is a big one. It's a single line in an overview slide, but I urge you to attend the sessions on object spaces. This is another example of where, and you'll keep seeing us do this, where we talk to a bunch of customers and we see how they're writing code, and we take that support and build it into the store. So a couple years back, we noticed them, probably more than 2 years now, we noticed that a large number of mid-tier programming models, or mid-tier applications, they don't have their application developers directly write against SQL Server. They instead have an infrastructure team that builds an object model, and the mid-tier programmers operate against the object model. It turns out it's a more productive environment. If you have every engineer in the whole operation writing SQL statements, invariably you'll get some bad SQL statements. So they've isolated most of their developers using an object model. Well, we're realizing we can do that. Customers using a graphical interface, in fact, it's the Whitehorse tool you saw this morning. Using Whitehorse, you can define, here's my object shape. Here's the objects that I want to operate on in the mid-tier. Here's the schema that I want to operate against in the back end, and I'll express a mapping between the object and the back end store. So once you've expressed that mapping that says, here's how the object's related to the back end relational schema, at that point, you're done. We create the object model. It's fully available to operate on. You can select objects using a language called OPath, so you can decide which objects you want to pull into the mid-tier. You can operate on them in the mid-tier. We track the changes that are made to them, and you can commit it and force it back to the server. So that kind of programming model that is really common is now supported natively by SQL Server. Query notifications. This is useful mostly for complicated multi-tiered applications. Very frequently, I find mid-tiers that have caches on board. You don't want to go back to the database for every request. The challenge here is you want to have a cache in the mid-tier. You don't want to go back to the server, but you don't particularly want to have stale data. So wouldn't it be nice if you could get notified on data changes? So now you can register a standing query with the server that says, say you've got all employees between A and F currently cached, or whatever query you've run against the server that filled the cache, you can now register that query and says, listen, if anything that I've got in the cache changes, notify me. So used for cache management. We've also integrated this support into IIS as well. So we have synchronized caching to allow us to cache dynamic content based on SQL Server reliably. If the SQL changes, the cache gets flushed. So you gets the right answer, yet still allows caching for dynamic content. The speed up is phenomenal. Asynchronous client access. This is an interesting paradigm that a small number of customers use, but it's super important. This small number of customers are guys that write mid-tier servers. When folks are writing mid-tier servers, one of the problems they face, if you have 10 or 15,000 connected users coming in, you need to multiplex with a thread pool all those connections coming in. We have great support in NT for doing that. And so asynchronous I/O is natively supported. As the requests come in, you can be handling completions. as the requests are going out, you post the write to the network and continue to operate. In fact, this is one of the reasons why we've won so many benchmarks with IIS over the past 3 or 4 years. The reason for it is asynchronous I/O. I'm sure there's a lot of other things going on, but async I/O is really important. The problem is these applications that run in the mid-tier, I told you how well they can handle the client access coming in. They probably have to do some data access. If they do data access, we block, because it's synchronous access to the database. So those threads get blocked, the pool gets drained, and the only choice is to start more threads. And so it's a less efficient model. Because we now have asynchronous support, that same form of support based on I/O completions that's available on the network tier is now available on the data tier. So now in the mid-tier, much more thread pools can handle a much larger number of connected users. And as a consequence, performance will skyrocket. The number of mid-tiers required goes down dramatically. So this is a feature that I wouldn't say is useful for everybody, but those that are using it are really going to profit from it. T-SQL, oops, pardon me, wrong direction. There we go, full text search. I talked earlier about one of the themes that we've got for this release is expanding the classes of data that we can store natively in the store. We want to be able to handle well less structured data. Starting in SQL 7.0, we offered full text search support, and we've made big changes in Yukon. These changes are being driven by the fact that around the Shiloh timeframe, that's SQL 2000, around the SQL 2000 timeframe, large numbers of customers are using full text search, and they're starting to scale it to numbers that we just didn't test it for. So what we're finding is we tested at the time to a couple million row scaling sizes. It was handling through the SQL 7 timeframe customer requirements really well. I was starting to get a lot of calls saying, it's taking a long time to index. We made phenomenal steps in Yukon on indexing. 2 orders of magnitude improvement. It's fundamental. So the scaling size that's reasonable for a full text search index now is up probably 3 orders of magnitude. We're testing on a couple billion rows. I believe it can scale well beyond that. We're seeing very close to linear performance. That's the biggest improvement we've made in full text search. That's the most important one, and that's the one I hear the most about from a customer requirement perspective. The second one is query performance. On the benchmarks we run is improved about 30%. Good, solid release to release improvement. Third class is administration integration. We've done a bunch of things from an administrative perspective to improve full text search. One of them is just tighter integration with the engine. Just like the way you create a normal index is create index, well, the way you create a full text index now is create full text index. So we've added DDL for full text search because it's a native part of the engine. It should be supported natively by the engine. Second thing is there's a few paradigms that are in heavy use by customers that we want to be able to support natively. One is large numbers of customers build a database offline, say a catalog database for an e-commerce system. They stop the access to the production system for a few seconds, disconnect the database that's there, connect a new one, and allow the connections back in. In the course of a couple seconds, they will have changed the catalog data that's available to the system atomically. We now make that work with full text as well. So in addition to having the database transferred, all of the full text indexes all go with it. Same with backup and restore. Same reasoning behind it, same value from it. In addition to that, we have some functional enhancements listed below. The most important one is multiple column support. You can now search through not just one column, but as many columns as you want. Thesaurus support's a fairly popular one. Let's look at the XML support. I'm going to start looking at XML first from a perspective of what are the driving scenarios? When is XML useful? Why would you want XML support in a relational database? So the first scenario, I think, is without debate. The first one says XML as a wire format, as an export format, is the right answer. The data should be stored in relational form, but it should be shipped to other applications in an XML form. There's no debate on this. In SQL 2000, we had great support for mapping between arbitrary relational schemas and arbitrary XML schemas. That support has gotten much stronger in Yukon. So this first scenario is one that we're handling well today, and you're going to like the improvements that we're doing in Yukon. The next scenario is the one where there's room for some debate. I want to tell you a little bit about that. Okay, so the next class is, the first class was mapping support. You're storing relationally, but you're transporting or sharing data in an XML form. I argue that there's another class of data. There's a class of data that never ends up in a relational store. And the reason it doesn't end up there is the schemas are dynamic. They're not all the same. Or maybe the schemas are poorly enforced. Or maybe the schemas are poorly understood. Or maybe the data is just dirty. But for whatever reason, it never ends up in a relational store. More often than not, its schemas are only partly understood. So those parts of the schema that are not well understood can be stored in an XML form, just left in an XML form. What that allows you to do is, if you've got data coming in from a partner, for example, the data that you need to operate on is stored relationally. The rest of it is round-tripped, just stored in XML form. It allows you to round-trip it back to the partner without any change to it at all. And the beauty of storing it natively is you actually can search it. So if you don't have any schema information on the XML at all, at least you can go through and say, find all the prices greater than 57. You can't do that with a full-text search. You can only do that with some form of XML-aware search. So we support XPath and a subset of XQuery on this data. So the second class is native storage of XML. And there's two ways that's being addressed in the industry. One is a large number of companies, surprisingly large number of companies, are trying to make a business building native XML stores. The problem with that is it's unusual that you want to only store XML. Usually, you'll want relational data joined with XML data. So there's another class of companies, of which we're one, that are adding native XML support to relational stores, getting all the capability and power of an XML store with XQuery over that XML data, but at the same time not giving up any of the relational support. Okay, here's an example of our XML data type. In this example, what I'm doing is I'm creating a table. It has two columns. The first column is an integer. The second column is an XML data type. The XML data type in this case is non-null, which is to say that you must have an XML document inserted. You can't leave it null. It could be a zero-length document, but you have to have a document there. Second example, here I'm creating an index. I've created an XML column. It's my choice whether I want to index it or not. If I'm only using the XML column for storage of XML and I'm never querying against it, there's no sense paying the price for an index. On the other hand, if you do search against it, an index is really helpful. Now, here's another example. This one I'm running in XQuery, and it's a surprisingly complicated small statement. What this does, it's a SQL statement that's selecting IDs and XML fragments. That small snippet of XQuery is doing two things. The first thing it's doing is it's searching through every row, through the XML in every row using an index and searching for all documents who have a document ID of 123. And for those that have a document ID of 123, if there's any section at any depth in the XML below that with a section number of greater than 3, it's finding that and taking the heading. So the first thing you see is going on here is we're combining SQL relational queries with XML queries. That's the first thing that's happening. The second thing that's happening here is we're reshaping the data. Normally, SQL queries are returning the primitive elements that are returned are what's in the database. Here, we can reshape the data. We're actually returning topics. You see what's happening is return topic is a new constructed element with the heading. So the data that's coming back, the XML that's coming back, is in fact a new shape that was never stored in the database itself. So it's a very powerful language, but with power comes a little bit of complexity. And for a lot of the customers that are using the beta program, what they told us is, wow, that XQuery builder that you guys shipped with the product really helped me get into this and understand XQuery. I'm actually finding it pretty easy to write. Where if you look at that and you don't know XQuery, it's not immediately obvious. So Tom, can you show us the XQuery builder?
Sure. First, I'll show you the native XML support, and then I will show you the XQuery builder to show you how we realize you're probably T-SQL developers, C#, VB, that you've never probably done XQuery before. and that you probably need some sort of designer like we give you for our data designers for the XQuery language. So the first thing I'm going to show you is using the XML data type. So we're back in our bike training application here. And you'll see in the cycle training, we actually create a table. And right now, there's no XML type in here. That's just all standard relational stuff. Small ints, nvarchar, identity columns, all those things that you're probably used to today. What we do then is we actually bulk insert a bunch of data into here. Don't worry about that. And then we alter the actual table contained. And this is how we set up the demo, and I'm showing you these steps. We add a new column of this XML data type. So it's native XML storage. If I wanted to, I could say, and the XSD schema that is required on this column, I could point to it. And I could say, also, you could put in documents that are either of that schema or untyped, or they have to be of my particular XML schema type. And then we just go through and do a bulk load of a bunch of XML data in there. Now, if we run against the data that we've loaded previously, if we do an F5 here, you'll see, hey, there's my relational data. And if I scroll over, you're going to see, hey, there's a bunch of XML data over here stored natively. And then we can index it and search on those things. But then if I said, hey, I don't want root and events and all this other garbage that's in my XML document. I want to just get at brass tacks. I just want to get at the XML data that I care about. We can do this idea of cross-domain queries, where we can put in our relational query, our T-SQL right here, our XQuery information. You see this funky notation, colon, colon, query, or colon, colon, something else. That means that we're going to do some other type of function besides an T-SQL statement. And then all we do is we use the built-in, still supported for XML auto to kind of nicely format that. So instead of talking, let's actually run this little relational query inside of here. And that's a pretty easy XQuery in there. That's actually very similar to, and there we go. There's our document. If we wanted to, we can come back and take a look at it and cross-domain on this. Now we could do other things, which is we can use inside of our queries, inside of our XQueries, we can say, hey, this comes from SQL. This is my SQL column. So we have both ways you can do cross-domain queries. You can use SQL inside of XQuery, you can use XQuery inside of your SQL statements. So let's just go through, select our SQL columns, and this should return back. This is a little bit harder one. I won't show you everything in there, but if we run that, we get another XML document, and if I click on it, we can go in and browse it and take a look at it, and it's actually, a much easier XML document to understand. Now, oh, people like that. All right, yeah. XML support. Yeah. Don't be shy. You like something, clap, go ahead, go crazy. Throw money on stage. I always like that. So the next point here, we'll show you this stuff later, is we're going to go in and actually show you the XQuery designer. Actually, I'm on the other machine. Back and forth. He slices, he dices, he juliennes. Let me get out of this for 1 sec. Oop. We're running these all in virtual server, the Microsoft virtual server. So I'm going to bring up my other virtual server here. If you haven't tried it, best thing to test, debug, code on, run, Longhorn and all the other things all on your XP machine. So anyway, enough about virtual server. You can see here's the new workbench. We have this idea in here, which is a new XQuery. So this will launch the XQuery designer. Not very exciting, just launching it. You have to start using it. And we realize writing XQuery may be a little foreign to you. So what I'm going to do is I'm going to go into my databases over here. And this is the workbench. And I'm going to scroll over to this database that contains one strongly typed XML column already. And you can see it's of type XML. I'm just going to drag it and drop it into the designer. And because I did the strongly typed, it automatically knows what my XSD is. But if I didn't have an XSD, it would try and infer what the schema of your XML was directly inside of the tool. Now the other thing that you do is it's a drag and drop environment. So if you're used to dragging and dropping information, it's a very, very easy environment to get started with. I want to show all of the information contained inside of my store information in my XML. So I'll just drop it on. You see it says, okay, you want to do an XQuery? I'm going to start writing the XQuery below for you. So keep watching that XQuery below. I'm going to run it, and you know what? I get back all my store information, which is things like books and DVDs and all the prices and the authors and those sorts of things on the bottom. Now, let's keep going. If we said, hey, I don't want just all my store information, I want actually just books. I want my query to return just books. I just drag drop. You'll see it will automatically realize, oh, you want to loop over everything and filter just by book. And then it writes the XQuery down there for me. And if I just execute, Now, when I scroll through, all I have is books. I have no DVDs anymore. So pretty easy. But it gets even better than this inside of the xQuery Designer. You may say, you know what, I want some rich filtering inside of my xQuery. So we have this criteria grid, which you can go through, select the book, and then I can just drag and drop. And maybe I want only books with a certain price above maybe $19 or something like that. So I'll just drag and drop into my field. It says, oh, it's in your namespace. Here's the price. So tell me what operator you want. You see it's writing the xQuery below for me as I select things. And I'll say every book above 19 bucks, apply it to books. I run my xQuery. Let me show you that it really works. So let's scroll down. You see this Benjamin Franklin book on the bottom is $8.99. It should disappear. Bam, there you go. J.R.R. Tolkien's Lord of the Rings. It sells for $19.99. We've showed it inside the xQuery Designer. But wait.
Not done.
Not done. I can't stop. It's so exciting. So here we can go back and take a look at our, if we want to add new things inside of here, again, it's just drag and drop information. So if I wanted to add back in DVDs, drop it in, it starts writing a more complex xQuery for me. Now I get all my DVDs included with all my books, and I can actually see all my information. So this is just a really quick tour of the xQuery Designer. You can build very complex sorts of xQueries and give us your feedback on this tool. We think it will help you get started writing xQuery and using XML and SQL Server.
Fantastic, Tom. I appreciate that. Yeah, one of the things that, yeah, good stuff. The beta feedback we've got on this is people are happy that we're implementing XPath and xQuery. Seeing us work with standard languages is a good thing. Everyone kind of agrees to that. But people are saying, thank you for giving me tools to make it easier to understand. Because xQuery, I don't find it the most accessible form in the world. Okay, let's skim along. I want to finish up the XML support relatively quickly, but one of the facilities that I wanted to cover for you is some of the extensions we've made to the mapping support that I talked about earlier. We're capable now of, we used to support annotated XSD. It's a richer mapping language today, so you can now map between stored procedures and arbitrary XML shapes, as well as the existing support for schemas. It's a little prettier format. It's a nicer format to work with in annotated XSD. What it allows you to do is you can create XML views over arbitrary data. The arbitrary data could be relational data. It could be in one table. It could be in multiple tables. It could have XML data types. Once a view is created, that view is queryable anytime, any place. So you can run XPath against the view to get different shapes of data. You can run XQuery against the view. Even more interesting, you can insert into the view. So for example, if you're working with a partner and they want to see the data that you're storing in a specific shape, you describe that shape as an XML view. At that point, you can ship to them the data that they need to see by just running XPath or XQuery against the view. Even better, as they ship changes back to you, you can just apply them to the view. We handle the mapping to the underlying store. Even better again, if you get large quantities of change at one time, we'll bulk insert them. Same thing again. So a step forward in functionality. It's doing much the same thing, but it's doing it in a richer way. Summary of the platform. From a platform perspective, what's going to be shipping in Whidbey is an enhancement of what was there in Everett. What's in Everett's actually very good. So this is just taking it the next step further. The key points on here, XPath 2.0 support is an important point. Very high performing XSLT engine. That's a big step forward for us. We'll be talking about many of these features in subsequent sessions, and I urge you to have a closer look. You've seen the investment across the company in XML and in web services. Having deep native database support for this is super important. Okay, let's look at web services and what's happening with Yukon and web services and how are we plugging into the Indigo web services framework and how are we allowing SQL Server to be accessed through web services. The reason we're doing that, there's two big drivers of this. The first driver is web services is very well supported from a tools perspective. This week you've seen some awesome demos of what kind of support we're putting into the underlying system for web services. It's good to have SQL participate in that. The second driver behind this is we want to have access to SQL Server from Unix systems, from Linux systems, from Mac systems, from any kind of systems. And it turns out a web service is a wonderful way of making SQL Server available. And so those are the two drivers behind the work we're doing. Okay, the support that's actually there is we can define endpoints into the store. The default answer is web service is not on. If you choose to turn the web services on, the default answer is nothing's visible through the web service. You select which procedures you want to publish through a web service, and it goes back to what I said earlier. You want to choose a high level of abstraction, so you choose what you want to actually show. Once you decide what procedures you want to publish and make available through SOAP, we publish the WSDL for it, and it's now available on the end of that endpoint. You can ask, what procedures are available, and we return the WSDL for it. That allows you to plug into other web services. The support is based upon fundamental kernel support in Windows 2003. The fundamental kernel support means that the calls are coming into the Windows kernel, and they're being directly routed out into SQL Server. There's no IIS involvement. There's nothing else going on. So from a performance perspective, it's impressive. Let's have a look, Tom, at what's possible with web services and how we've got this integrated into SQL Server.
Okay, let's switch over. We'll show you just a really quick demo of web services. I'm not going to do it justice because it's an entire session on it.
It's a river.
But what you're seeing here is I've got my workbench open inside of Yukon, and I can scroll through into the new programmability tab inside of here, the folder hierarchy. And I can go through and I have a T-SQL stored procedure named P_select doctor. And then I have another one which is insert doctor, which allows me to actually select doctors from a database and insert doctors into my database. And we're going to expose both of these out as web services. So you see a little bit of my code over here. We have some new data definition language built into Yukon, which is this thing called create HTTP endpoint. So it's a little bit of syntax that you're going to have to learn. You may be wondering, hey, why didn't we use the nice little web method that Visual Studio does? Well, you have some magic underneath there that gives some metadata inside of Visual Studio that we can't get when you're running within a SQL Server instance. So you need to tell us what site you want to publish it out to an IIS, and what path, virtual directory that you want to provide, what ports you want to use, what type of security and authentication that you want. And then you may be wondering, hey, what's this for SOAP? Well, we realize in SQL Server that there may be times when you want to have your web services work over other protocols rather than just SOAP. So this is why we built this into this definition. So you could say, hey, for TCP, for UDP, for SMTP, whatever sort of protocol that you want. Then there's your nice little web method. I fought hard for this naming of this function. So Shriek can tell you about that in the session over beer, maybe, all the hard fighting that I gave him on this. But we called it web method in the end, thank God.
Good job.
And so you can define what you want that function to look like when in your WSDL. And here's our mapping. So we say use that P_select doctor from our database. We have one for the insert below. But you can see most of this is directly inside of the data definition that we have here. So instead of talking to it, let's actually run this. And there we go. The command completed successfully. Let's go and actually take a look at what it looks like.
So what we have at this point is we now have a web services endpoint that exposes that method.
Exactly. And so I'm going to come in Visual Studio. You can do this from InfoPath, which we showed earlier this morning. You can use your standard add web reference inside of here. And you get the new WIDB adding of a web reference. And we can browse all the web services on the local machine. I'm running on my SQL Server box. And you'll see this Contoso doctor, which maps to that virtual directory that we published out our endpoint to. If we click on that, it's going to query it. It takes it a sec. Takes it a sec. Okay, there we go. We see now we can see our endpoint. We can see all of our parameters. And you'll see that it even knows that we're returning it back as a SQL results stream, and we're actually inserting in as SQL results and all these different things. So we're running out of time. I won't show you actually coding against this, but you can go to Shriek's session on web services and learn a lot more about it. So,
fantastic. Key thing that you ought to get out of that is we now have the capability of selectively exposing those methods that you want to expose outside of SQL Server. It can now be published out in a broad way. And so if you have systems in the network that are running Linux or running any other operating system. You still have access to SQL Server. That's super important. The second thing that's important is to leverage the Indigo infrastructure. Indigo has done a phenomenal job of routing messages, and we want to make that same framework available to SQL Server customers in extremely easy fashion. So this is integrated tightly with that. I'm going to look last at 3 major application frameworks. And the key thing I'm going to emphasize here is what you've heard throughout this whole talk is 2 common themes. The first theme is making industry-leading tools available to server-side developers. The second big theme is that we spot common programming paradigms, common cliches, or common patterns. If we see a pattern that's used by a large class of our customers, we integrate that into the server. It helps make people more efficient. It allows our product to be implemented more cheaply. And 3 that I wanted to talk to you about were the service broker, notification services, and reporting services. Let's start with looking at the service broker. A large class of applications are written with noticing this. Instead of having each request that comes into the database be a large monolithic transaction, what customers realize is, in fact, I'm better off running a very small transaction and deferring some of the work to later. So the way Service Broker works is a broker is defined as a queue, and broker itself is some executable code. And so it allows you to take monolithic transactions and break them into pieces. So as a request comes in, very cheaply, that request the operations that need to be completed synchronously are done synchronously, and the remainder of the work is plugged into the queue. The reason that's efficient or effective is, number one, taking an application apart into individual pieces allows maintenance more efficiently. The second reason is the queue provides dampening of performance. That's important. As the workload goes up and goes down, the queue provides a damper, so you don't hit into a hard wall where customers start to not get service as a consequence of overload. The queues just get a little longer. The third reason is a queue processor that's doing change operations is less likely to deadlock. If you have 10,000 users coming in at the same time, the chances of deadlock if an application is not written carefully is fairly high. If all of those customers are queuing their changes up, and there's queue processors operating, those queue processors are less likely to self-deadlock. So easier to maintain application paradigm, easier to develop application paradigm, and it turns out it's a very common way of writing code. This is how SAP is written. SAP makes the minimum change possible, queues the rest of the work, and it has queue processors. So that's now implemented natively as part of SQL Server. You can define a code, you can define a broker, which is code that's executing, and that code can run either in the server or outside the server. You can define queues for the work to be enqueued to this broker, and the support is all there natively. Second is notification services. It's really popular right now to be able to directly touch customers, directly contact customers. Common uses of this are weather reports. If you want to know about if you want to know if there's changes in weather, things like that, you can get notified quickly. If you want to notice that whenever a customer buys batteries, you'd like to contact them and recommend that they consider their tire sale. Anything that's based upon data changes is a chance to touch a customer. And so customers are writing large applications that are tracking data changes in their databases and doing things with customers, either notifying sales reps or notifying customers directly. We've built in support to do this on a scale that goes to tens of millions. So the infrastructure is extremely performant. It's simple, but the key thing is extremely performant. The final one is reporting services. Value in the data is the key thing. We want to be able to deliver value in the data. And many of our customers are buying reporting services, and it's an extra cost purchase. Why not make it available natively, part of the system, no extra cost, just part of the system. It's part of delivering value from the data. So there's a separate talk on reporting services. I urge you to attend it. It's a very rich set of functionality. It's available here. You can go and get a copy of it right now and run it. It's impressive and very, very useful. It's in beta, second beta right now. So I'm going to wrap it up. What I've told you about today is the third phase of database evolution. This is making systems programmable. We've talked about the .NET integration and the power of that. We've talked about improvements to ADO.NET. We've talked about extending the types that can be efficiently stored in the database, including XML. We've talked about full-text search, and covered very briefly 3 new application frameworks. Really appreciate you coming in to learn more about Yukon. It's an honor to be able to tell you about some of the development work that we're doing. Thank you, Tom. Appreciate the help with the demos.
No problem.
Thanks very much.